Okay, let's go on. So figure 12, look at A. That's some of your Libyan desert glass. And as it says, it's displaying tubular glassy texture. You see the tubules? Okay, so then we have B, which is from Abu Huraira, and it is disturbed by chaotic plastic flow and embedded in a vesicular calcium oxide rich matrix. And so here what you have, this is being interpreted as evidence of an atmospheric detonation, releasing tremendous amounts of thermal energy and literally melting the surface of the desert. Okay, that's your Libyan desert glass. Mike's going to give us a date on it. I had the date at my fingertips.
26 million years.
Sounds about right. So think about that, man. And the temperatures have got to be up a couple of thousand degrees Fahrenheit, at least. And what's this? What's the aerial extent of it? Is it about maybe 7,000 square miles? Does that sound about right?
I have a map if you'd like me to share it.
Well, you sure? Why not? Yeah, that'd be great. There we go.
Yeah, and it's I found it says several thousand square kilometers is the extent.
Several thousand. Okay, yeah. So I was off.
Literature values on the extent vary between about 2,000 and 6,500 square kilometers.
Oh, okay. Yeah, okay, yeah. So flash that back up there again, Mike. So we can see the extent of. So part of it is in Egypt, part of it is in Libya, hence the term Libyan Desert Glass. Well, there you can see its relationship to Egypt. You see Cairo up there. You see the Nile River along the northeast quadrant of this image right there, and you see Cairo up there, which would be the site of the Great Pyramid. So I would guess, wouldn't be surprising that some of this Libyan desert glass found its way into the Egyptian, perhaps using it in jewelry or effigies or whatever. Is something interesting to research. And I may have seen something on that. I cannot recall right now, but I believe that there is some finds in Egypt where they were using the Libyan desert glass. So here we've got this comparison between Abu Huraira and Libyan desert glass. Abu Huraira, presumably 12,900 years ago, Libyan desert glass, as we just learned, 26 million years ago. And yet the assumption here is very similar. The idea of the genesis of the material at Abu Huraira. Notice it's calling it lachatellite tubes. Tubes. When you have a volcanic eruption and you have a very fluidized magma that comes out, you oftentimes will form tubes. Okay, so now we get to the trinitite. And here you have an assortment of backlit translucent trinitite shapes. Number one is called an accretionary, because notice what you've got there is a spherulitic form, and then two more objects have accreted to that. You see that, the idea there? You've got the spheral, and then one and another under the high temperature, high pressure gets slammed into it, and then accretionary means it accretes, right? Accretionary. So then it gets welded onto the larger one. And so number one, spherulitic, or number two is spherulitic. Notice number two is very elegantly spherical. And then number three, right here, broken teardrop. You see they've cut off the tip of this thing, but you can kind of see if you took it, it's broken. So undoubtedly, again, evidence of likely the shock pressures. But then that tip, see, so it's rounded at the base, but then it's pointed like a teardrop. So this is a very typical shape that you find in these byproducts of these high energy events. For example, tektites, which we'll be looking at pictures of, you'll have teardrop shapes are quite common. And tektites are molten, crystallized out of the molten, presumably passing through the atmosphere, taking on those shapes as they crystallize. Then number four, bottle shaped. Right. So what they're doing is they're showing out here the diversity of various shapes that these things can take. Number 5, dumbbell. And you do actually see sometimes in tektites very distinct dumbbells where it's like almost like two sphericals, but they're welded together by this much narrower dynamic diameter section and have this very much dumbbell-like appearance.
Or it's like a spinning droplet or something that
Yeah.
it's like stretching
Mhm.
apart and having the two spheres on the end.
Yeah, yeah. And then number 6, as it says, is elongated or oval. Then when we get over to B, that's your edge-on view of a pancake trinitite with a smooth top. Number 1, there's the smooth top. And a vesiculated interior, number 2, showing here you see the vesicles, the hollow spaces, and a dark bottom composed of partially fused rounded trinitite objects incorporated with surface sediment. So it's picked up some of the surface there that has been fused onto the bottom of this particular piece of trinitite. So this is just by example for comparison to impact proxies. And interestingly, by studying the effects of these nuclear weapons explosions, we actually do gain a lot of insight into cosmic impact phenomena. Even cratering, things both on the micro and the macro levels. And so we're going to have an episode where we really look in depth at the whole nuclear testing program and extract some insight that will help us understand these the cosmic processes that we're trying to learn about here. All right, check this out. There's a piece of Libyan desert glass right there. The origin of desert glass is uncertain. Meteoritic origins have long been considered possible, and recent research links the glass to impact features such as zircon breakdown, vaporized quartz, and meteoritic metals, and to an impact crater. Some geologists associate the glass with radiative melting from meteoric large aerial bursts, making it analogous to trinitite, created from sand exposed to the thermal radiation of a nuclear explosion. Libyan desert glass has been dated as having formed about 26 million years ago. Like obsidian, it was knapped and used to make tools during the Pleistocene. So again, during the Trinity that was the first testing of the atomic bomb in New Mexico. And like Tunguska, which exploded in the atmosphere, the Trinity explosion was, I don't remember the exact height of it, but it was well up into the atmosphere. Because if it hits the ground, like in the case of an impact, if it hits the ground, a lot of it's still going to be enormously destructive and violent. But a lot of the energy is then absorbed into the earth itself. Whereas if it blows up in the atmosphere, there's nothing. I mean, the radius of destruction is going to be much greater. And so when they tested the atomic bomb, I mean, they were assuming, the physics of it told them that, well, if we detonate the things in the atmosphere, they're going to be more destructive than if they actually hit the ground and explode. And so both the Hiroshima bombs and the Nagasaki bombs, people might think, oh, you drop a bomb, it falls down, and then it hits the ground, hits the earth, and then it explodes. But no, these things were set to actually explode in the atmosphere so that the radius of destruction was maximized. Okay, so that's our Libyan desert glass. We know the timing of it about 26 million years ago, which is interesting. 26 million years, that would be 1,000 precessional cycles of the Earth, for whatever that might mean. Just an interesting little coincidental sideline.
Yeah.
1,000 precessional cycles. And when we get into getting into looking more at the archaic and ancient traditions, and we really delve into the ancient concept of the great year, then we will find this recurrence of the multiples of the Earth's precessional cycle of 26,000 years. And here's another image of trinitite in its more raw form, also known as atomsite or atomsite. I don't know how to pronounce that, or Alamogordo glass. It's the glassy residue left on the desert floor after the plutonium-based Trinity nuclear bomb test on July 16th, 1945, near Alamogordo, New Mexico. The glass is primarily composed of arcosic sand composed of quartz grains and feldspar. We don't need to get into all of that. It is, as it says, mildly radioactive, but safe to handle. Now, again, the point here is that the Libyan Desert Glass, what do you got? You've got this melted sand sheet from a presumed atmospheric explosion. So it's being compared to what trinitite, which was formed by a plutonium bomb explosion in the atmosphere that was hot enough to melt the sand. So you see there's these parallels between these two features. So now we're getting to light photomicrographs of magnetic and glassy spherules from Melrose, Pennsylvania. Shapes include spherules, ovals, teardrops, and dumbbells. And colors include clear, gray, red, brown, and black. Note that spheral B, look at this, spheral B, we've seen a picture of that before, right? But let's come back to it, contains a large bubble. And then you've got D, look at here, here's your dumbbell kind of shape. Look at D and H, where you've got two spherules that hit with such force that they just welded together. That's clear evidence of non-normal processes. It's clear evidence of very high energy processes going on here. So if you find these things, like in Melrose, Pennsylvania, where they're found right at the base of the black mat at the Younger Dryas Boundary. So you have to be able to come out and be able to explain what kind of a high energy event could produce things like you see in D and H.
So the typical regular infall of cosmic materials don't have these characteristics?
No, because it's a very gentle process. Just you got to imagine this little microscopic grain just, gently falling to the earth. And, these things are raining down, but they're widely dispersed. And again, it's not a high energy. There's nothing that would cause two of those spherules to be forced to welded together. Just like here, it says D and H indicate the fusion of molten or semi-plastic spherules.
Right. So they would have had to have formed in some other high energy impact somewhere else to rain down on the Earth in that form. Right.
But they're not found in this form.
Okay. Right.
So that's the whole point. I mean, that's one of the characteristic things that you immediately can differentiate and say that these are not the normal rain of cosmic material to Earth.
Okay.
Because you don't find this. And if you did, it would have had to have been created somewhere else.
Right.
Which is probably not out of the question. But note, as it says here, that H consists of two dissimilar accretionary spherules. The clear one is silica rich, so it's almost like clear glass, and the other is iron rich. So on the left, silica rich, on the right, iron rich. And then here, G, there's your teardrop shape. Interesting. And then the different colors, which of course are going to be a function of composition. But these are the kind of things you look for under the microscope. And they're tiny, tiny. So you have to be very diligent about your sampling and what kind of technologies that you use to identify these things. It's one thing to see actually what they look like, and then something else again to be able to actually determine the cosmic chemistry of these things. A on your left, a pooled trinitite. So this is what it looks like on the desert floor. In situ trinitite on the ground after the Trinity nuclear bomb detonation. Width of the view here is about 20 inches, and B is a large piece of trinitite, and the up side you see was upward facing as it lay on the ground. So we can learn about these high energy events by looking at nuclear detonations. You recall that our discussion of the Oralton Farms mastodon, just to kind of go off on a tangent for a moment. Remember the Oralton Farms mastodon discussion?
I remember two of them. One of
Yeah.
them was which one?
The one that was crushed where the foot was in place.
Yeah, the
Yes,
footprint.
That's the one
yes,
I'm talking
yes,
about.
yes.
So here you got a picture of mastodon ambling across the through the forest floor, because mastodons were probably in the forest because they were browsers. In other words, they like to eat branches and leaves and things like that. Whereas mammoths were grazers. That's an important distinction between the species of mammoths and mastodons. Anyway, so this mastodon is walking along and the ground is soft. So as he's walking, his feet are sinking into the ground, maybe 4, 5, 6 inches, 8 inches. Mastodon's going to weigh 4 or 5 or 6 tons. So he's pretty heavy. He's going to sink into the ground if it's soft at all. Now, all of a sudden, some force knocks him over. Both of the femurs are snapped, right? The entire skeletal is forced, probably pushed ahead, and the leg shears from the foot, which is embedded into the ground, right? Okay, so in trying to picture what kind of a force could produce such an effect, again, we can turn to nuclear testing, and we'll find out some pretty. We've got some, yeah. So
this is like shockwave forces, right? I mean,
Yeah.
yes,
they're at such high pressure that they start traveling faster than the typical, speed limits of the medium because they're creating a new medium.
yeah. Okay, so here I would suggest is what we're talking about. Here we go.
Yeah, I see your point. I see what you're showing there. Yeah.
Yeah, yes,
You get set on fire, and then the shear forces the shockwave comes across, and
yes.
yeah.
And the shear forces just are moving actually horizontal.
Right. Yeah.
Yeah.
And that's
and
what
you
we
can see it actually pull back, like right after that. It goes out and then it pulls back.
There's a
That's
suction
the-
back. Yeah.
Yeah,
Like
because
the
it's
rarefied
sucking,
side of the shockwave.
it's sucking back into the vacuum.
Yeah.
And
Yeah.
and you know that's the effect we see at Tunguska with the trees splayed out in every direction,
right.
right? The shock forces have just mowed them down like a
Right.
bulldozer.
And was that one of the fossils that also had evidence of where they were saying like the state of the bones show that that there was burning while the flesh was still there? Is that also
No,
one
I
of
don't
those?
think they I don't
Okay.
know if they were looking at that, but yeah, I mean there are other.
Okay.
I mean, I think on Santa Rosa Island is where we saw that there was a mammoth,
Yeah.
and yeah, I mean lots of evidence, because we're going to continue to talk about the evidence for global firestorms, because that's
Right.
a big component of what happened. Because to me, what's fascinating is when we get into, we're mostly dwelling upon the science here, but at the same time, we're going to look back because there are archaic traditions that I think are describing all of the kinds of things we're talking about here. The fact that it comes down, we have traditions that have come down from very olden times, very consistently from all over the world, about this bimodal destruction of the world, this bimodal periodic destruction of the world by alternating flood and fire. But actually, when you look at the traditions themselves, there's more than a few where the flood and fire are actually part of the same process. And usually it's the fire that precedes the flood, which is very interesting.